So today we are going to talk about map making. So although map making can be translated to cartography, but we don't really get into cartographic details, as this course is more like technical about coding. But there's an advertisement here for another course that I teach in May during the intensive period. So it's a 4-week course in cartography. And there we continue like the same line. So it's a continuation of this AutoGIS course. But we get into more details of like the coding, but also the artistic aspects of cartography. But today we are like very mechanical, just looking at how we can produce maps. So if you're interested in cartography, I recommend you check that course out. Even if you don't want to take it, it's similar format as this course, so everything is online. You can just check out the website and access the materials. So as I already mentioned, we are going to start with static maps. So we have produced some maps already from week 1. But today we add a bit more details and see how we can, for example, add a base map. And for many of us who have taken this course or have learned to use Python for GIS, this has been a major motivation. Because depending on how you produce maps, it can sometimes become annoying to be limited by those software. A use case of, well, of course, with programming, you have a lot of freedom how you want to do things. But also if automation is something that you do often. So if you have to produce maps in large scale, is it like business? Are you selling maps? You know, there are many of those websites nowadays. You can just print a map of Helsinki for your wall at home. So if that might be a use case, you automate the process. Or if they ask you to produce a map of all neighborhoods in city of Espoo, and there are tens of them. So do you want to go one by one and produce the map, or you just automate the process, you export, I don't know, 50 maps at the same time. So that can be the motivation. And then interactive map, of course, as I mentioned, there are a lot of limitations if you don't know programming. So we can see how that works. So the learning goals for today, so create the static thematic maps comprising multiple data layers using GeoPandas and Matplotlib. Learning how to add base maps. So that's something we haven't done yet. So we'll learn how to do that today. And then we work with a new library called Folium. And we will use Folium to create interactive maps. And we will see how we can enrich our interactive maps with some additional features like pop-ups and these tooltips that you can add to your map. So that's the agenda for today. We're going to start with static maps. Let's open Noppe. I already have the lessons here. And we are going to start with the static maps. So I guess it was the first week or second week I showed you a visualization of some of the libraries that are out there for doing GIS and more specifically for creating maps and visualizations. So in Python, there is a very rich list of different libraries you can use for visualization, especially for interactive visualization. So here we just work with Folium, but for example, in the cartography course, we also look at the Plotly library and a few others. So here we just get a few examples, but there are many more to use and learn out there. So we'll start with the static maps, and for that we are going to stay in GeoPandas, and as you have seen many times, GeoPandas uses Matplotlib under the hood to produce the static visualization. So we are going to work with GeoPandas and Matplotlib. The data that we will be working with is the same as last week. If you remember, last week we were working with this Helsinki region travel time matrix. And we had, well, as I mentioned last week, it has hundreds, if not thousands, of CSV files. But we were just looking at one of them, which had the travel times to Helsinki Central Railway Station. So we continue working with the same data set. This is already stored in our data directory. And we also add another layer to our map. That's the metro network of Helsinki. And that one we will get online from the WFS interface of the city. And yeah, so that's what we are doing in the first part. So let's get started. as usual, in the first cell, we just define the path to our data directory. In the next step, which is the most exciting part because we are getting data from WFS and you never know how it works. It worked fine for me. So we are getting the metro data and the road networks from City of Helsinki Map Services. When we are importing, it's a good habit to have this set. When you're using WFS, it's a good habit to have this set CRS. The information about the CRS usually comes through WFS. So when you use WFS, if it's done well, it will know that, okay, this is the WFS. But sometimes it's missing. So it's a good habit to just say what it is. I know this is the coordinate system because I've read the metadata. So I've read the information on the website, but it's a good habit to have that anyway. So it's in 3879. So we are going to make maps. And as I've said almost every week, when working in Python and whenever there's any kind of overlay, it's important to make sure that the coordinate systems are matching. Now we are making maps and we are adding several layers to the same map. So it's essential that it's important that they are in the same coordinate system. That's why we have this assertion line, checking if the coordinate system is the same for these 3 data sets. So let's run this. And we can see that they're not matching. So as you can guess, the roads and metro are coming from this WFS. So they're both probably in the same coordinate system, 3879. But the grid data, which we imported from our data directory, is probably in a different coordinate system. So let's just check out. So roads is in 3879. The accessibility grid is in 3067, this EUREFIN projected system that we often use in Finland. And then the other one is also in 3879. So let's take them to the same coordinate system. So roads and metro go to the same coordinate system as the accessibility data. And to double check that everything is in the same coordinate system now, I rerun the assertion line. And this time I don't get an error. So we are ready to start plotting our multi-layer map. Okay, so let's spend a few minutes and do this on our own, and then we can do it together, because we have been producing maps already the last few weeks. So create a map of the layers you have, and just repeat basically what we did last week. So add the metro line and the roads to your plot, add different colors, and do a bit of classification. So let's spend a few minutes on this. Do it on your own so you remember how we have done this previously. Then we do it together. So plot the accessibility grid using quantiles as your classification scheme, and then add road network and metro lines in the same plot. Okay, so let's look at my code. I was writing it at the same time here. So did anyone manage to produce a map? Yeah, so some of you did. So probably I've done something similar. I have added a few details that we haven't seen before. So let's walk through it quickly. Yeah, so I'm using matplotlib, creating a plot. Like you have seen already in the first period, we are specifying this figure size, the column that you are going to do the visualization based on. This we saw last week, the classification method, quantiles, the color map. As we saw last week, there are many built-in color maps or color ramps in a matplotlib, so I'm just using one of the ready ones. I'm going with a spectral. You might have something else. I guess a spectral goes from blue to red. Line width 0. I don't want to show the line width, the outlines, and alpha. So alpha is a measure, you have an argument you can add to adjust the transparency of the layer. So it's a value between 0 and 1. And the smaller the value, the more transparent the layer will be. So I'm adding a bit of transparency here. Then I'm adding the metro to the same plot, same axis, and I'm using a color orange and applying a bit thicker line width, going with 2.5. Then I'm adding the roads similarly, just using a gray color. I don't want to highlight them too much, so I'm going with something more neutral, and I don't make it as thick as the metro lines. The next thing I'm doing here is defining basically the zoom level or the extent of your map. So I'm doing it, of course you can do it manually, but I'm reading the extents of my data automatically. So if you remember from first few weeks, from the geodata frame you can use total bounds, which returns to you those 4 values. So it gives you the minimum x and y, maximum x and y. So it gives you the extent, and so you can just use it easily to adjust the extents of your map. So if you want to cover the whole data, then you can just go with total bounds. But of course, if you want to zoom in on a certain area, then you have to manually say which bounds to use. So let's run this, and if I don't have any typos, it should work. And this is the map I get as the output. So you can see the grids in the background. They don't have the outline because we turned off the outline. We set it to 0. And we have the roads appearing as gray and the metro lines as orange. So this is already a decent map. So compared to before, we have added more layers and adjusted a few things. But we are going to add even more elements to our map. So next thing we want to do is adding a legend. So, and I guess we saw it already briefly, but we didn't talk about it so much. But when you're creating your plot, there's a parameter that you can set to true or false. By default, it's false, so it doesn't add any legend. But if you set it to true, it's going to add a legend to your map. So let's try it here. And this is what you get. So the legend is added. So one thing that we are missing in this example is the scheme. So we are not classifying our data. So when you don't have classified data, you are essentially working with a continuous range of numbers. And what happens when you create the visualization and add a legend, Matplotlib automatically adds a color bar for you. So this is not a legend like with classes. So this happens automatically. So if you don't have any scheme defined, it will add you a color bar like this. So it will be a continuous scale. So why this matters? Well, first of all, this is the output you get, but also the object that is producing this for you is not actually a legend object. It's a color bar. So if you're checking the documentation to see how to change the looks of this, then you should check the documentation for color bar. This is not a legend. So there's a link here You can check. So there are some parameters you can specify to change the behavior. So one of the things is a location. So by default, it just appears on the right side of your map. But if you want to change the location, you can just add more variables here, more elements. So in the legend keywords, you can use any of these essentially. So if you want to change the orientation or fraction or different things, you can just pass in the variable as it's here. So let's try it with location. So I will change the location to one of the options that are available here. So you can put it on left, right, top, or bottom. So by default, it was on right. Let's see what it would look like if I put it on the top of my map. So like this. So this is just one example, but there are many arguments you can just adjust. Just remember that this is a color bar. So in the documentation, look for color bar. So there are a number of things. So one thing that you will see a lot when working with visualizations in Python, there are so many things you can adjust that there's no way you can remember everything. So the documentation is your best friend when producing maps with Python, because it's hard to remember everything unless you really produce the same map every day in your life. Yeah. So that's what happens when you don't have a scheme. So you don't have classification. But when you actually have a classification, like in this example here, so everything is exactly the same as before. The only difference is that I'm adding a scheme here. So I'm going with quantiles. The rest is pretty much the same. So let's just run this. So it will automatically, because the data is now classified, it will automatically create a legend for me like this. So it adds the classes. So this is important to know because, of course, this is what you get as the output. But also, if you are checking the documentation to move something around, for example, then you should check the documentation for legends, not color bars. So it's a bit different. So some things are slightly different. For instance, if you want to change the location, in the legend it's called look, not location. So here it was called location. And because it's a color bar, you had only 4 options. It can be like one of the 4 sides. But with a legend, you have more options. It can be different angles, different corners of your map. So let's try this now. So I'm going to change the location of my legend. But this is not ideal because it's a bit overlapping with my map. So I would like to put it, for instance, here, so it won't overlap as much with my map. So I'm going to change it to right bottom corner, and let's see how we can do it here. So the options are lower, so I can just type in lower right. There are also these short numbers for it, so you can also provide 4 for getting lower right. And changing it is similar. So in the legend keywords, I will add a new item, and from documentation, I know that it was called look. And the value I'm providing was it either right, lower right, in quotation mark, or just go with 4. So you have both ways. So as you can see, it just moves the legend to the bottom right corner. There are also, if you go through documentation, there are also ways of exactly pinpointing the legend to a certain location. So you can also work with coordinates. But usually one of the built-in values works. So there are many things you can change. Another thing you can change is the number of columns. So for instance, now all the values are appearing in one column. So if you want your legend to have multiple columns, you can adjust the encalls. Yeah, it's called encalls. And you can say, for example, my legend can be in 2 columns instead of 1. And then you can see the values show up in 2 columns. So as I said, there are many parameters you can adjust. So whenever you have a need for it, just check out the documentation and see how you can make your legend look better. Okay, so one other thing that we might want to add, and it's often a good addition to our maps, is a base map. So in cartography, we always say that, well, everyone is used to adding a ready base map, but from a cartographic point of view, it's not always necessary. So especially not the ready ones. So sometimes you may want to add other things in the background. But if you want to add a base map, one of those online maps that we are used to, then there are libraries that allow you to do that fairly easily. So there are a few libraries that can make it very easy for you. The one that we are using here is a library called Contextually. So it's already installed in your environment now, but it's a separate library. So if you want to add base maps just in your own work environment, just remember to install that. Contextually, and there's a link to the documentations if you want to learn more about it. So one thing to remember when working with web maps is that you're getting your web map from an online service. And one thing to remember is that map tiles from online map providers are typically coming in Web Mercator projection, so in 3857. So to make it work best, it's a good habit to transform everything you have to Web Mercator. So now we have 3 layers of data: the metro, the road, and the grid. So if I want to add a base map, it's a good idea to take them all to 3857. So this is what I'm doing in the next step. So I'm transforming my grid data, my metro lines, my road network to this Web Mercator. What happened? Yeah, so otherwise it may happen that they don't overlap. So now everything is in the same coordinate system in Web Mercator, which we know is not ideal, an ideal projection. But if you're using web maps, then you don't really have many options. So yeah, so now that everything is in the same coordinate system, let's go ahead and add the base map. So to save time, I have left some of the code here, which is the part that you just produced the map. So this is the same as what we have done so far. The only difference is that now we are going to import the library Contextually. Then we are creating the map, nothing new there. To add the base map, you have to add one line of code. So from Contextually, which is the library we just imported, I access a function called add base map. So add underscore base map. And as arguments, it needs a few things. One of them is the axis to which you want to add the base map. So we want to add it to the axis that we just created. The next thing you need to provide as an argument is the base map you want. So it has a bunch of built-in base maps. You can check out the documentation. There's a long list. I will show you soon. But for now, let's just add one that I know. So source, because I want to use some of the built-in base maps, this is how you do it. So from Contextually, I access the providers that they have already defined in the library. And there is a list of providers you can choose from, and I will show you the list soon. But I already know what I want, so I will go with OpenStreetMap, Mapnik. So it's a base map provided by OSM. So import the library, add a base map, add it to the axis that you want, and then provide the source. So with one line of code, you can easily add a base map. So this is OSM added to your map in the background. There's another thing that you can adjust here, and that's the alpha value. So if you want to adjust the transparency of your base map, you can just specify it's an optional value. By default, it goes with the 0 transparency, but if you want to adjust it, you can put a value between 0 and 1. So now I increase the transparency a bit. I put the alpha 0. You can see the base map is more transparent now. Okay, so that was easy. So about adjusting the zoom level, well, one huge difference here is that when you're working with visualization in Python, you don't have that interactive environment. So for example, for adjusting the zoom level, you cannot just use your mouse wheel like we do in QGIS or ArcGIS. So you have to work a bit harder for adjusting the zoom level. In the static maps, that's by adjusting the X-lim and the Y-lim. We already saw that. So you can get it from the bounds of your data. But very often you don't want the data the visualization to end abruptly where your data ends. So very often you will see these kind of examples. So you're defining the margin for your visualization. Very often you see people adding like 20% to each side. So you have a bit of extra space just to make it look nicer. So you can add a bit of some margin, some distance, or just add some percentage, add 10% to each side. So just an extra note if you want to make your maps look a bit nicer, try to use these margins. But back to the base map. So from Contextually, if you want to get a list of the providers, of course you can check their website, the documentation, but also directly from Python you can get a list of providers. So you can basically use any of these as your base map. But it's not as easy. But you know, some of them may not be free. So for some of them you may need an API key, you may need an account. So for each of them it might be different. So if you test, some of them may not work as easily, and you need to make a sign up, get a key, and work with it. But for example, OpenStreetMap works very nicely, and many others here. But usually what happens is that you have to try a few of them. So if you want to go with the built-in providers, then there's a long list, so probably you will find whatever you need. But if there is some specific map that you want and is missing from here, for example, I want to add Google Maps to my base map, and I can see that I can't see Google Maps. But you know that very often for different base map service providers, you can find these XYZ tile links. Have you worked with them before? For example, in QGIS, you can use the XYZ link to add a base map. So I have put one note here for you. In the shared folder, there is a quick notes. So I have found the Google Maps XYZ link from somewhere. They don't publish it publicly, but you can find it by Googling. So most service providers have this kind of link available to you, like with OSM, it's something. So another thing you can do instead of using this is to replace. So if you don't want to use these built-in providers, you can essentially replace this part with a link with these tile links. But the format is usually like this, and you can get it from just searching around. So if this works fine, it should add the Google Maps as the base map here. Yeah, so now I have Google Maps in the background. So there's a long list of built-in service providers to choose from, and if you're not happy with the list, you can just find the link from the service provider that you want to use. So yeah, so this is a long list of different providers, and very often different providers might have multiple layers you can use. For example, OSM doesn't have just one base map. We just use Mapnik, but you could have used also other layers that are available through OSM. So it can be the case for many of them, that they have multiple layers available. Okay, so now we already know how to add a base map to our static map, and that was quite easy. The next thing I'm going to do to make my map a little bit better depends on what you want to actually do. So I want to zoom in to the center. So let's look at a subset of our data. So I'm going to recreate this visualization, but this time only keeping the places which are less than 15 minutes away from the railway station. The rest is basically the same. Let's just run this. So I just selected the part of data, and since I'm not explicitly defining the X limb and Y limb, it just adjusts the zoom level so it's covering your data. Yeah. So another thing that you usually need to add to your maps is some kind of attribution text. So very often you want to acknowledge the data providers. Sometimes you want to add your own name if you're publishing the map. So with contextually, you can add a keyword, an argument called attribution. Inside it, you can pass a string with a text. You can add whatever attribution you want to your map. So very often for example, the data we are working with, well, we have OSM base map, so I'm giving them credit that this is OpenStreet map base map. And the travel time matrix is coming from Digital Geography Lab, so I'm giving them credits. So just attribution. So let's run this, and you can see the attribution is added automatically to the corner of your map, the text that you provide. So this works, for example, very nicely with OSM, because OSM is not very picky with attribution. Some of the map providers, they force you to use their own attribution. So for example, if you're using Here Map or Esri Map, they might force you to just use their own attribution. So if you try it with those, it could be that what they are forcing will just override your attribution. So it may not work. Then you may just need to add it as a text number. But yeah, for OpenStreetMap, at least the attribution works very nicely. Okay, so that was making a base map. So we added a few details. We learned how to adjust some things in the base map, in the static map compared to what we had done before. And now it's time to move on to the next part, which is the more fun part. So creating interactive maps. So I will go back to my work folder. So when it comes to creating anything interactive on the web, it's very hard to compete with JavaScript. So now we are in this course learning Python, and you know that in the world of web, when you're creating anything interactive, JavaScript is the most powerful language to work with. But we are working in Python, and Python, well, is a language that we are comfortable with, but also we are doing our data analysis in Python. So you are working with GeoPandas, you have learned how to work with your data, so it's convenient to stay in Python environment, especially if you're not comfortable with JavaScript. So the good news for us is that there are a number of libraries, such as the one that we are going to work with, Folium, that are essentially so they are a Python interface of those JavaScript libraries. The Folium that we are working with is essentially using Leaflet, which is a known library in JavaScript for creating interactive maps. So if you're using Folium, you're actually using JavaScript. It's just Folium is doing the translation for you. And that's why you will see soon there is a bit of like weirdness in how you use Folium, because some of the things are coming from JavaScript world. For example, we will work with geodata frames, but this works with GeoJSON, for instance. So we have to take a few extra steps that might be a bit weird, but they are because they're coming from the world of JavaScript and other libraries. But yeah, so the good news is that many of these libraries that are common in JavaScript are also available in Python, but through other names. So if you do a bit of search, you can find some of them. But today we are going to work with Folio, and there are some useful links. There are a lot of details. There are many different kinds of maps you can produce with Folio. So if you really want to master the library, I advise you to check out the documentation. But now we will learn a few of the more important stuff. Okay, so we start with creating a very simple interactive map, starting with just the base map, then we add details as we progress through the lesson. So as usual, in the first cell, I'm defining the path to my data folder. I'm going to export my map later on as an HTML, which you can just share it with others or host it on your own website. And for that, I'm working with a different, so I'm defining a path to an HTML folder. And here I've added this MK there. So if the directory already exists, it's okay. Because otherwise, if there's an HTML folder, then you will get an error that this exists. So I've set it to true here. So if you run this several times, you won't get an error. Okay. So it created the HTML folder for you with make directory, and I put exist OK. So if you run this again, you won't get an error. Otherwise, you would have gotten some error. So now I'm going to start producing my interactive map. And as a first step, of course, I'm going to import the library that I will be working with, and that's Folio. And this is how you create an interactive map in Folio. You create an object, a map object, and this is how you can do it. So I will give it a name. I will call it interactive_map. And this is how you create your interactive map object. From Folio, I access map, and the M in map is capital. Then you have to provide a few arguments, values for a few arguments. So one of them is location. So you have an interactive map. So what is the starting point? Of course, you can zoom out, move around, but when you load the map, what is the center? So for that, you have to provide coordinates. So I go with 60.2 and 24.8. Yeah, and if I remember correctly, it's somewhere in Kumpula, the coordinates. Another thing you have to define at the beginning is the zoom level. So when you just load the map, what is the starting zoom level? And for that, there's a variable, an argument called zoom start, and you can provide a value. And what is a good value? You can usually figure out by trial and error. Just try a few numbers, see what works best. I've tested this before, and 10 looked like a good starting point. And then if you want to add a scale bar to your map, you can set control scale to true. But to add it to your screen, make sure that you put the name of the map object here. So it is created, but to have it added here, I just put the name when I run it. So you just created your first interactive map in Python. So let's say you have the base maps. You have a base map there. We didn't change anything, so by default, it just went with the OSM mapnik. We will see how we can change that, but yeah. So you have a base map that you can move around, zoom in, zoom out. Well, this is essentially an empty map with just a base map, but let's already see how we can export our map. So we had created a map with the name interactive_map. And for saving it, you can just use .save. And the only thing you need to provide is the path to your HTML file. So where do you want to save it? So if you remember, we already had created a directory. It was called HTML directory, like the path. And inside that directory, I want to create my base map and name it base-map. And remember to add the suffix. So this is an interactive map. So a common mistake is that some might try to save it as a JPG file or something. You need to save it as an HTML. So let's just run this. And it gets saved. So if you check inside the HTML folder, if you open it, so this is a map that you can just share with anyone, or you just can put it on your website. So whatever map you produce with Folium is easy to export. With just one line of code, you can get it as HTML and share it. So now we didn't change the base map. It went by default with OpenStreetMap. Let's see how we can change it. Yeah, so let's recreate our map object. So you remember that you can do it by folium.map with M capital. So I retype. You can also copy and paste from what we wrote earlier. I will just type it again. So 60.2, 25.0. I will change the zoom level a bit. So I changed it to 12. Last time we had 10. So here is how you can update the base map if you don't want to go with the default. So there is a parameter you can pass called tiles. And for tiles, you have to provide the name of the base map. And the naming is a bit different than contextually. So check the documentation and see how they are named. But now I go with one that I'm familiar with. So I'm going with CartoDB positron. So CartoDB positron. So this is this gray, very neutral base map that we have probably used a lot in QGIS or somewhere else. And then just remember to add the name of the variable so we can see the output. So check out the documentation. So there are some built-in map providers. You can see their names here. So you can just use the name of some of the providers and just change this. So let's just run this. So this is the CartoDB positron, so another base map. So you can easily change the base map. So for changing the base map, you can either go with the providers, very similar to contextually, they're just named differently. Or you can use a link. So similar to contextually, instead of this name, you can just put a link. So the same link that we had used here in the first part of lesson for Google Maps, you can just test it here. It will give you a similar output. So I will test it now with the Google Maps to see if it still works. So we had the link somewhere up here. So I can replace tiles with this XYZ tile link. And some providers will force you to use attribution, and this is how you add attribution in Folium. So ATTR, and then you can write something. So I'm just using Google Maps, so I will give them credits. Yeah. So this is Google Maps, so you can just replace this name with any link you want, or go with one of the built-in built-in options. Okay, so that was easy, but you rarely produce a map to just share a base map, because they can just go to OSM and see the base map. So you often have your own data and you want to add it to the interactive map, and that's what we're going to do next. So let's just start with an easy example. So in our first easy example, we just add one marker manually to the map and see how that works, and then we continue with the bigger data. So first bit is the same, just creating the map object. The new part is that I'm going to create a marker object. So in Folium, you create different kinds of objects and then you add them to your map. This is the logic. So I'm going to create a marker object, and name it Kumpula. So I'm going to add the coordinates of Kumpula here. And this is how you create a marker object. So a marker object works for if you want to just add one marker to your map. So Folium.marker. And it expects a few inputs from you. So one of them is the location. So where should the marker be placed? So I have the coordinates for Kumpula, 24962. So this will be somewhere in Kumpula. I'm going to add another feature to my marker, and that's a tooltip. So when you hover with your mouse over the feature, it will have this pop-up appearing with some information. So what do you want the pop-up to say? It will just say it's Kumpula campus. Then for your marker, you probably want some icon, some symbol for visualization, and so you have to create a new object for it. So you create a Folium.icon object. And here you can specify, for example, what is the color you want to use. I will go with a green color. And for your icon, you either have your own image, you can give the path to the image, so if you want to put your own symbol, or you can just go with one of the built-in features. And from documentation, you can see a list of these. There is one that I'm going to use, and it's called OK sign. So I'm going to use an OK sign and turn it into green. So now you created your marker object, but remember that you still need to add it to your map. So I already had created my interactive map, so I will add the Kumpula to my interactive map. So essentially for anything that you want to add to your Folium, different layers, different kinds of objects, you just create a new object, then you add it to your interactive map. So let's just run it. Yeah, so you see the map is created, and you have one marker object with this OK sign added, and it's in green. So adding a marker to your map using Folium is quite easy, but very often you need to work with a data. So unless you are just making one visualization, you have an event and you want to show where the venue is, you might do something like this. But very often if you're doing like real GIS, then you have a data set you want to visualize. So let's see how we can actually add a layer of points. And for that, we are going to work with a data set that we worked with a couple of weeks ago. Remember, when we were working with geocoding, we had a bunch of addresses that we geocoded using OpenStreetMap. So we are going to work with that data set. So from data directory, I'm going to load that addresses.gpkg. And I will print ahead so we remember what we have. So you're getting a warning that you have multiple layers here because we had the original data, then we added a new layer with the geocoded addresses. But anyway, by default, it's reading the first layer, so it's fine for us. So that's what the warning is about. So this is the data that we had. So we have the addresses, and we had geocoded it using OpenStreetMap. So we have the coordinates there, which is great because we need the coordinates to add them to our map. So let's see how we can add this to our map. So first part is the same as what we have done several times already today. Creating an interactive map with Folium. Everything is the same. Some center point for my map, some starting zoom level. And for creating, for adding the layer, again, I need to create a new object. The name of the object is different this time. So I will call it addresses layer. And this is how you will create, this is the kind of object you need to create for adding a vector layer to your map. So from Folium, I'm accessing features.geojson. So that's a bit weirdness, or not weird, but just suddenly you're using GeoJSON, which is common, like in JavaScript in the web world. It's a common geographic data format. So what you're doing, you will work with your geodata frame, but Folium will do the conversion because Leaflet works with GeoJSON. So this will convert without you doing anything, converts it to GeoJSON that can be used by Leaflet. So I'm creating my GeoJSON features. So what is the data that you're going to use? Is the addresses. This is the data layer. And you give your layer a name. So I will name it public transport stops. And again, remember that once you create a new object, you need to also add it to your interactive map. So addresses layer is what I just created, and I use the same function called add_to add it to my interactive map, which I created earlier. Yeah. Yeah, I had a typo here. Or what? Can you see my typo here? Yeah. Yeah, this one, yes. Yeah. Yeah, so we had a layer of points, and we added them to our map. So this is, yeah, okay. Okay, one thing we didn't test up here was this tooltip. So when we created this cupola point, we had added a tooltip, so you see how it works. So when you hover over it, you will get this text added, or displayed. Okay, another thing we want to add to our map right now is a pop-up window. That is also a useful feature for some maps you might, well, for interactive maps, it's a common feature. For that, we have to create another object. So let's see how that works. So the first step is the same. I'm creating my interactive map. Nothing new there. The new thing here is this pop-up. So I'm creating a new pop-up object, and there's an object called GeoJSON pop-up under folio. So I create that. So what information do you want to have added to your pop-up? So I want to read the contents of a column name address. So we had a column in our data address, so that will be added as pop-up. So if you want to give a nickname, for example, the address was with a small letter, so I want to have it capital letter, just a visual thing. So if you want to give it a nickname, here you can give a nickname. Localize true, like if you have some like language specific features, because you are working with an interactive online map. So if you have something that is localized, like if you set localized to true, it might do some localization depending on where you are accessing the map from. Labels and style. So you add some base color map, then there are background color. There are many to choose from. But let's run this and see what we get as the output. And the next thing is the same thing. So we had created this features GeoJSON, so we are adding the layer. The only difference here is that remember to add your pop-up. So here you create your pop-up object. Here, when you're adding your layer, you should specify that, okay, this pop-up that I just created up here belongs to this layer. And then you add the layer to your interactive map, and that's it. So this is your pop-up. You see the name is appearing as the nickname you provided. So with a capital, the contents are coming from your address field. And it has a yellowish background that you just specified. You can choose different colors, different values. And yeah, so you just added a pop-up. So, which is a nice feature of interactive maps. Okay, so this is how you can add a layer of points to your folio map. But what if you want to work with a polygon layer? So in the following part, we are going to revisit another data set which we have worked with before, and that's the Helsinki region population grid. So we are going to get the data directly from WFS. So let's just run this and get our data. So I had added this part of code last year because last year there was a problem with service, so there was some certificate issue. We were getting some error with SSL. I guess they have fixed the problem, but this line is from last year. But if you were running into SSL issues, then this can help. But otherwise, it's the usual WFS request. You're getting our population data and printing the head here. So we have seen this before. It's the grid of data with the population information. So I do a bit of data cleaning first. We have many columns and the names are in Finnish. So let's clean up and translate them also to English. The code is typed in, and this is something we have done many times. So I will only keep the index column and the information about the population and the geometry, of course, and I will rename it to population in English. So let's just run this. So now the data should be clean. You can check it, of course, with .head. So for adding a layer of polygons, we are going to work with a different object again. So we are going to use a different kind of map, and that's a choropleth map. So it has a lot of features. It does many things automatically, usually in a nice way. So it's more than just a simple map. So if you check out the documentation, you will see that it can take care of many things. But it has a few special needs that you have to take care of. One of them is that it assumes that you have a geospatial data that has only coordinates, only geometries. Then you have another attribute table. So it always assumes that they're separate. Because very often, like if you're working with geodata frame, you have one table that has geometry, but also population and everything. But the assumption here is that they're two separate. So you have the geometries in GeoJSON, then you have a separate table. So what it does, it always joins them. And for joining, it needs an ID field that has to be a string. So just remember, this choropleth feature of Folium assumes that you have a table data and you have your geospatial data. And they're joinable using a column named ID or anything, but that ID has to be a string, not number. So what I'm going to do now is to create that ID field, and that is very easy. So in my population grid data, I will create a new column named ID. So the contents of this column are basically my index. So I will just use my index. But remember that it needs the contents to be a string. So I don't change the number, I just convert them to a string. So they will be still the same index numbers, but as a string. So this is one extra step you're taking because of how this library works. And I guess this is the weirdness I was talking about. It's coming from JavaScript and it's a bit different. So with my population grid, I added a column and I'm naming it ID. It can be named anything. And it has to have a string, unique string values. And the easiest way is to just go with this index values and convert them to string. So let's just run this. And now if you look at your data.head, you will see that the column is added. So I will just copy the name .head. So you can see you just created a new column that has numbers, but the numbers are string this time. You don't see it here, but they are a string. Okay, so now that we have that column, we are ready to do the mapping. So the first beat is the same. I'm creating my Folium map object. Nothing new there. The new part is here. So I'm going to create my choropleth map based on my population data. So I will name it population grid layer. Population grid layer. And in order to create a choropleth map, you access Folium choropleth, and the C is capital. So if you're working with Polygon, the best way of adding them to Folium, the easiest way is through choropleth. So these are the things that this object expects from you. As I said, it expects you to provide a separate geographic data under an argument called geodata. So what is our geographic data here? The population grid. So what we have in our case, we have a geodata frame. So everything is in one place. So I'm just tricking Folium. And I'm saying, so this is your attribute data. This is where you have all those other columns. In our case, it's the same thing. And it's okay, because it just ends up doing an unnecessary join between the table and the same table. So this is weird because it, as I said, it expects you to have a separate geographic GeoJSON data and then some attributes. But in our case, they're both in the same place. The next thing you have to provide is the columns that you want to include. And of course, you want to include the ID you just created. That will be used for joining. And then you want to use the population, of course. That's the main thing you want to visualize. In your geographic data, what column are you using for the join? So you have to say for key on. So this is the column in your geographic data that will be used for joining. So in your attribute table, it's ID. What will it be in the other one? So it will be also ID. But because it's coming from GeoJSON, this is how you access a column in GeoJSON. So from feature, you access ID. That's why you have the feature. So it's essentially that same ID field you created. But because it's being converted to GeoJSON, that's why I write feature.id. Again, one of those weirdnesses that I talked about, but once you know what you're doing, it's not that difficult. So now we created our population grid. And we have to still add it to our map. So again, using the same add to function, I add it to my interactive map. Okay, so you get the output. So you have the map, the interactive map, and the grid map grid is added there. And Coroplus, a nice thing about it is that it automatically applies some coloring for you. It does some classification. So if you are in a hurry and you quickly want to create a map, interactive map, this Coroplus makes your life easier. But of course, if you want to change things, then you can also change things. So let's look at the code a little bit. This is often confusing for many. See if every part of it makes sense to you. If it's all clear, then we can continue, but look at it a bit. Okay, so you understand what's happening here, right? Great. So it automatically created a map for you that has a lot of features. So it has the legend added, it has some coloring, so you might be already happy with this. But as geographers, of course, we want to make our maps even better. So I'm going to do a few things to make the map look nicer. Like it's doing some classification. I'm going to make it a bit more detailed. So I'm adding more bins to my classification. And I'm going to change the field color that is used in my visualization. And I don't like these grids. With grid data particularly, this outline just makes it very unreadable. So I'm going to get rid of that as well. And that's what I'm doing in this next part, and everything is typed in. So let's just look at it and see what is happening. So the first part is just the same. Second part is also the same, just a few things are added. So I'm specifying the number of bins that are created in the classification. For field color, it uses similar color coding as Matplotlib. So the value is the same as the C map that we used earlier today. So now I'm using a color from yellow to red. So you can go with different built-in colors. The line weight, so the wording is a bit different. In Matplotlib, it's called line width. In Folium, it's called line weight. So just remember, line weight is set to 0, and I'm adding a name to my legend. So I'm calling it population 2020 because that's where when the data is. This is the period the data is from. So let's just run this. And I have highlight set to true. So highlight is this feature. So when you go over a grid or a polygon, it just highlights it. So it's a nice feature. If you set it to true, that's what you get. And then, of course, I add it to the interactive map, and this is the map. So the map already looks a lot nicer. You got rid of the lines. You added this highlighting feature, which looks nice. And then you improve the color a bit. So for population density, I don't know what you think, but I think population density, this color coding looks a bit more intuitive for showing population density. But yeah, so the map already looks a lot better. I'm going to add one more thing to my map, and that's a tooltip. So remember, in one of our earlier maps, we had this feature that when you hovered over an object, you had this pop-up showing up with some information about the feature. So one thing is that choropleth map that we use for visualizing our polygon doesn't have that feature. So we cannot just use we cannot easily do it in choropleth, but we are going to do a trick. So what we are going to do now is that we continue working with the same map. And remember, so far we have every time recreated this, but you don't really need to do it. So if you're continuing working with the same map, this is defined, so you can just change things. So we continue working within this interactive map. So what I'm going to do to get the tooltip, we already saw how you can add the tooltip easily using this GeoJSON tooltip. And this GeoJSON tooltip works with this features.geojson that we used before to add points. Do you remember? So I want to use this features.geojson to get the tooltip because it's easy from that, but I don't want to have two layers at the same time. So what I do, I add this GeoJSON, but I make it fully transparent, so you don't really see it in your map, but the tooltip functionality is added. So remember, we have the choropleth map that we have produced, and we are very happy with it, like this. But to get a tooltip added, choropleth doesn't have that feature. So I will add another layer, this one. This is what we did earlier for the points. So I'm adding the features GeoJSON, the population. So I'm adding population grid twice. Once is in the choropleth, once is just on top. But I don't want it to appear because I already have it. So I make it transparent. So the color is transparent, the outline, the infill color is also transparent. So you don't see any difference. But with this added, you can also create this. So you can create this tooltip object that works with features GeoJSON. So I will add the population tooltip here. And I'm adding the whole thing to the interactive map I had created before. So let's just run this and see what I mean by this. So now you have essentially two layers on top of each other, but one of them is invisible. You only see the tooltip. So now you could add this tooltip feature to your map. So many people love Folium because it's very powerful. It's annoying, but it's powerful because it uses Leaflet, and Leaflet is a very powerful library. But because it's been like translated kind of to Python, it has these weird things. So yeah, so I understand if some may not like it, but it's a powerful library. So there are also many professionals who use it quite actively. So think about this part of code for 30 seconds and see if it makes sense to you and see what we are doing. Do you understand how we added the tooltip and what's the logic behind this? And for a styling function, so if you want to add a styles, again, you can check the documentation for details, and I've added some comments here. But if you want to have a specific styles for your map, in Folium, you need to create a function. So you create a function like this, like define a style function. Then you can add like color, fill color, line weights, different things. Then you pass the function to your object. So here, style function, you can use that function. So if you want to customize the looks, then there are many ways how you can do it. Okay, so that was what we wanted to cover for today. Just as a quick reminder, like I said, Folium is just one of the many libraries that you can use for visualization. There are a few others. There are many others, actually. GeoViews is another library you might be interested in. Mapbox has Also a library for visualization. Bokeh is a library that has been around for a long time, and it's also, some people like working with it. I personally like Plotly. Plotly, yeah, so in our cartography course, we use also Plotly. So Plotly is a bit more intuitive. For example, compared to Folium, it doesn't have those weirdnesses, so I personally like it better. Yeah, so Plotly and Plotly Express is also are quite good for interactive visualization. And it's not just maps. You can make very interactive, nice plots and charts with it as well. And they have very good libraries, so examples, like they have very good documentation. So with Plotly, you can create so many different types of maps, as you can see here. And if you check out one of them, yeah, it gives you very detailed instructions how to make that kind of map. So you can just replicate it in your own study. Yeah, so Plotly works very nicely. But yeah, in this course, we work with Folium, which is a bit annoying, but very powerful. And once you're done with your work, you can, of course, export your map, like I do here. It's saved as an HTML, which you can share with people or just put it on your website. Yeah, that was it for today. Have a good evening and see you next week. So next week I will try, we still have 2 more weeks, but next week I try to already share the final assignment. So you're going to start thinking about it because the deadline is quite close to the holidays. Yeah, see you next week.